Hello students, we will continue our study with regard to the evolution of skyscrapers, and in the previous presentation starting from Chicago school I had taught you how the skyscrapers became a totally new built form in the modern times. How in the Chicago school the preconditions for the building of the tall buildings was firmly established, whether it was to do with the foundation or the elevator or the steel frame that was to form the structural frame of the skyscraper. All these things were sorted out, and by the time we step into the 20th century we find that a very definite form and shape of the glass and steel skyscraper comes in front of us, particularly with the contributions of architects like Mies van der Rohe. And these skyscrapers are moment frame skyscrapers. With regard to the structures of skyscrapers, we will have a later presentation after this where we will talk about the structural systems that have evolved in skyscraper design. But those were the early days of the steel cage moment frame skyscrapers, and that was worked upon, and by the time we reach the middle of the 20th century, a lot of these skyscrapers are being built, particularly in Chicago and New York. And as we move into the 70s and 80s, other skyscrapers start coming up, which based upon new kind of structural systems that were designed by Fazlur Khan, a Bangladeshi structural engineer working with Skidmore, Owings and Merrill, and we'll talk about him later. He gave us the basis to design various kind of skyscrapers with regard to their structural system. So very innovative forms started coming up: bundled tubes, tube in tube, hybrid tube system skyscrapers came up, and a series of skyscrapers in the 70s, 80s and 90s. We will be looking at some of them in the presentation on structures in skyscrapers. But predominantly the other changes that happened with regard to skyscrapers was they became very innovative. Ideas that were starting to come into other areas of architecture like environmental consciousness, bioclimatic design, green building design, energy sustainability, all these features started impacting skyscrapers or tall building designs also. Now there was a study done by the Corporation of London, tall buildings and sustainability, and they found that skyscrapers are not only an inevitable building form, particularly for urban areas, they are also more environmentally sustainable than smaller buildings, predominantly because they have a very small footprint and they do not catch or they do not cover as much of green spaces or land mass to build them. So we come to the concept of an ecological skyscraper or a bioclimatic skyscraper, and the example we have in front of us is in the 1990s, the Commerzbank in Frankfurt by Norman Foster in 1997, 299 meters tall, 56 floors of 56 number of floors in the building. 299 meters means it's just a meter short than it would have become a super tall skyscraper. Now tall office buildings are an efficient use of the limited urban land. The primary design concern earlier used to be operational efficiency of the skyscraper rather than the environmental impact it was causing. But gradually, as we reach the end of the 20th century, there is a new balance that needs to be struck between operational efficiency and environmental efficiency. Both have become important in equal measure. Now, what is the difference between an ecological skyscraper and a bioclimatic skyscraper? An ecological skyscraper responds more to global issues of concern. For example, the focus of an ecological skyscraper happens to be that it has a global environmental impact. Its design strategies are focused on renewable energy, smart technology, global sustainability. The scale of concern again is to deal with the global issues with regard to carbon neutrality, that is the making carbon emissions neutral, or to the overall resource efficiency globally. And the examples can be the Edge in the Netherlands or the One Angel Square building in the UK in 2013. The bioclimatic skyscraper on the other hand has got local issues of more concern, like the local climate. It has to adapt to the local climate. Passive design is the backbone of a bioclimatic skyscraper. Passive design for thermal comfort and for energy savings. it responds to local climatic and environmental conditions. And this building by Ken Yang, the Minara Meseniaga in Malaysia, is an example of the bioclimatic skyscraper. A bioclimatic building today, due to the development of many digital tools that we have, every element of such a skyscraper can be adapted to microclimatic conditions of a place. So, very fine tuned bioclimatic buildings can be designed today. Commerzbank in a sense is both an ecological and a bioclimatic skyscraper. It responds to the local conditions, yet it also uses building management systems and high energy management systems, both of these ideas in the same building. It seamlessly integrates climate responsive architectural principles that are in tune with the local climate, and yet uses environmentally sustainable design strategies in its design. So, when we look at the bioclimatic features, it has got the provision of natural ventilation, that is operable, openable windows to provide fresh air circulation to reduce the reliance on mechanical ventilation. It has got an amazing concept or an interesting concept of sky garden. As you move up the Commerzbank tower in a spiral, you find these 9 sky gardens located all over the skyscraper, and they provide buffers against the heat, they provide therefore natural cooling, and they also help in improving the indoor air quality. How are they arranged in the plan? I will show you a little later. The spiral arrangement also brings in sunlight throughout the day depending on the orientation of the sun at the time, which part of the building you are, which sky garden face you are in, you will get the sun at that time of the day. So, the atrium opens to one of 3 sides on any given floor. The sky gardens, which are one of the core concepts of the Commerzbank and came into a tall building in the 1990s with this building, it allows more fresh air and natural light and reduces the need for artificial lighting in the building. It ensures that offices in buildings have 2 other sides, in buildings 2 other sides, that is, which are not the sky garden but the office sides, they have either a view looking out towards the city or a view inwards looking towards the garden. So, if you are in this office somewhere on this floor for example, you can either get the view of the city, or you can get, if you are on the other side of the plan, you get a view of the sky garden, and so it is true here also. So, one view you will definitely get. Not only that, they have followed the German code that no seat will be more than 7.5 meters away from a window. Therefore, all people working in this office space get a very good view of the outside wherever they are in the plan, in the floor plan of the office. When it comes to daylighting, this central atrium space that has been provided, it pulls in natural light deep into the building. It minimizes the need for artificial lighting. In the facade design, there is a double skin facade that has been used here, and this insulates the building. It helps in adapting the building to temperature changes, and while it helps in maintaining indoor thermal comfort of the building. Now, this concept of sky gardens in a tall building then really caught on, and many other architects employed it. For example, Rafael Viñoly employed it in 2014 in a building called the Walkie Talkie Building in London, and this is the sky garden we find at the top of the building here. And then we have the Bosco Verticale in Italy, where Stefano Boeri provided the entire building 2 residential towers completely having vertically integrated gardens throughout the building. So, we find these vertically integrated gardens throughout the building. This is one of the balconies of the towers. Or in the CapitaGreen in Singapore by the Japanese architect Toyo Ito in 2014, he incorporated these sky gardens in the building. India has not been left behind. In a building called the GYS Vision coming up in Gurugram, but designed by Morphogenesis, it also has this spiral-like arrangement of sky gardens that we find in the Commerzbank, and this is the visual representation of that sky garden. Now, what is the advantage of the bioclimatic building when it comes to energy savings? So, if I was to compare the Commerzbank, which is a bioclimatic skyscraper, with a conventional skyscraper like the City Corp Center, I find that the conventional skyscrapers are sealed and centrally controlled, centrally climatically controlled. Whereas the bioclimatic skyscraper is opposite of that. It has got passive controls. It relies on the outdoor climate for maintaining passive thermal comfort indoors. And whereas this building, the City Corp Center, has got active control. As a result of this passive control and dependency on the weather outside, the Commerzbank is able to save 30 to 50% energy with regard to a conventional skyscraper of similar size. So, in the passive strategies, every office receives natural light and ventilation. And like I said, in compliance with the German building codes, all employee workstations are within 7.5 meters of a window, whether looking towards the city or looking inside towards the sky garden. When it comes to the detail of the double skin facade and the window and heating and cooling ventilation strategies, this is how they have achieved it in the typical office. You can study it in detail online. This is copyright of Foster and Partners because they specially have designed it for the Commerzbank. When it comes to passive strategies, when the weather is suitable, the heating cooling systems inside the building are automatically switched off and a green indicator light switches on inside every office, which indicates that now the windows can be opened. Now, can we open a window so easily on the higher floors where the wind speeds are high? For that also there is a provision. They have got a protective outer layer of glass and the windows can safely be opened in high winds, in driving rain or on the highest floors without causing any kind of damage. So, because of this lighting up of the green light, so that we do not need heating cooling systems, as a result of that, this green light lights up approximately 1/3 number of days throughout the year. That means 25 to 30% of energy saving takes place versus a comparable skyscraper. When it comes to the plan, that also is very efficient and a very unique design. It has got a triangular plan or a 3-petal plan, like the 3 petals of this flower. These are floor zones and within it is the stem, which is a full height central atrium that brings in natural light deep into the building. The 2 wings, these are the 2 wings which are the offices, and the 3rd wing is the sky garden, the 4-storied sky garden. The petal and stem design brings harmony between the employees and the environment because of the way the building has been created or designed, and the plan is also linked with the company's logo of Commerzbank. Now, when we come to the plan in terms of its structure, we will not go into details of all the structures of buildings in this particular presentation because like I said, we will talk in detail about structures in that presentation on structures in skyscrapers. But talking about structures in this, because it is very unique, it has got these pair of vertical masts like this on the corners, and on each corner these vertical masts enclose the services and the circulation. There are floors between the sky gardens. There are floors between the sky gardens, as I show you the section here. There are these floors between the sky garden, floors in between them. These floors are supported by 8-story high Virendale beams or Virendale frames that also resist the lateral load. Now, what are Virendale frames? Virendale frames or trusses vary from other triangular trusses in that the bracing is not diagonal. The supports are not diagonal, but like you see in this Virendale truss bridge, the supports are vertical. So, if you look at it here, you find in these floors, these are Virendale framed or Virendale trussed floors and the supports are vertical. So, you can imagine it is like a bridge, and in case of a Virendale frame, you can have large spans, So, if you take this plan of the building, there is this large span across the office floor and then there are the Virendale supports on either side. So, what it actually is that you can think of this bridge, that the bridge is the complete floor and these are the Varindal frame supports on one side and this supports on the other side. So that is how the floors are. Varindal supports on one side, Varindal supports like that, and so the Varindal frames build these 8-story floors in between the sky gardens. This kind of Varindal beam or truss structural system has also been incorporated in the Strait Trading Corporation building by Raj Rewal in New Delhi in 1989, which is it was at one time the tallest building in Delhi. Now when we come to the corner mass, they carry the concentrated gravity load to the ground, but the Varindal trusses also help to support gravity loads of the sky gardens and the floors. They transfer the load again to the vertical mass and then down to the ground. But along with that, the Varindal trusses or frames also help to resist lateral wind load. So the overall structural system of the Commerzbank is very unique, and Norman Foster has been observed to develop unique structural systems for his buildings. Later on, I will talk to you in structural systems about the HSBC, the Hong Kong and Shanghai Corporation building in Hong Kong, where he uses an exoskeleton to design or to put together his building, and that is a very unique structural frame. So this is one thing you will find in the works of Norman Foster. Now one more thing that is now becoming important in the urban skyline when it comes to skyscrapers is lighting design. Because of the way the size of the skyscrapers and the way they are in the urban skyline, if you light them up particularly on their pinnacle, they really provide a tremendous urban aesthetic to the city at night. And therefore the yellow lighting of the Commerzbank, the scheme has been designed by Asadullah Aftab, and it is important for exterior lighting in these buildings, in contemporary tall office buildings, and it is happening throughout the world. You find that in China, you find that in the Petronas Tower in Malaysia, you find that in the One World Trade Center in New York. So across the world, whether it is in Germany, China, Kuala Lumpur or New York, this kind of lighting systems are being used. Coming to the next building, again by Norman Foster and very similar in its basic concept to the Commerzbank, is the 30 St. Mary Axe in London in 2004, about 7 years after the Commerzbank. It was commissioned by the Swiss Re company, one of the world's leading reinsurance companies. It included 41 stories of offices, 76,400 square meters of floor space, accommodating offices and a shopping arcade, and a highest level restaurant in London. Conceptually, Swiss Re develops the ideas that have been explored earlier in the Commerzbank. So instead of having outer facing sky gardens, the Swiss Re building, also called the Gherkin, there is another name you can read up online, so do not get confused if you hear this title, it is also called the Gherkin. So this building has indoor sky gardens also going up in a spiral, and it has a central atrium just like the Commerzbank. So you can see that these are the spirals that are there where the indoor sky gardens are. They are not actually green spaces, but they are part of the atria and provide outdoor spaces for people there. It has got a radial plan. Again, Commerzbank, like the Commerzbank, Norman Foster goes in for an innovative structural system. He goes for a digrid frame, and we will talk about it. It has got a radial plan which widens as it rises. It widens as it rises, peaks out at the restaurant, and this is where the restaurant is, and it tapers then towards the apex like this. Now the slimming of the profile toward the base helps in maximizing the public space at the ground level. Advanced double glazing facade has also been used here like in Commerzbank, and it has got low reflectivity glass so that it can improve the visual comfort and the aesthetics of the building, along with providing greater energy efficiency and greater contribution to sustainability. It is an environmentally sustainable skyscraper The floor plans are circular perimeter which are indented by these 1, 2, 3, 4, 5, 6 triangular light courts. The floor plan is rotated for each successive floor, creating a series of spiraling 5-story atriums or atria that stretch the full height of the building. The windows in the atria, they open automatically to augment the air conditioning systems with natural ventilation when it is so desired, and this saves energy up to 40%, just similar to that as in the Commerzbank. These are the two plans. When we compare them, we find these atria spiraling upwards, and Commerzbank similarly has these sky gardens that are spirally arranged in the building as the building rises. Now when we come to the natural ventilation system, the Swiss Re or the Gherkin has an amazing idea in that the 6 triangular light wells arranged spirally work like natural ventilation shafts. The air comes through the operable windows on the, that is the windows operable on the facade, and this is the double skin facade. Now what happens is that because of the round shape, because of this round shape, the air flows like this around the sky tall building rather than straight bumping into it as it would have happened in a cuboid. Because of this, the external pressure differentials there between the windward and the leeward side are reduced, and wind deflection is reduced. This helps in drawing air, it helps in drawing air across the building without much resistance. Secondly, it helps in pulling air into the double skin facade upward or downward into the building. So when we look at the double skin facade and the air being pulled in, it works as a giant double glazing effect. First, as a thermal buffer zone between exterior and interior. When there is air inside it, it acts as a thermal buffer zone and controls the thermal comfort indoors. As air is sandwiched between this, it increases this passive indoor thermal comfort. Then the atria dispels most of its heat energy that comes in through the glass envelope. So the double skin facade plays that role also in dissipating the heat energy generated from the atria. Then the digrid frame. The digrid frame is basically a triangular grid frame. You can call it digrid is diagonal grid. It allows column free floor spaces, fully glazed facade, and opens building to light and views. So you get wide expansive views as a result of the digrid frame, and it cuts down on internal supports. So you require minimal internal supports when we are using a digrid frame, and hopefully we will have a presentation about digrid buildings separately to discuss about the structural system in the modern times. It allows for naturally broad apertures, naturally broader opening, and we find it in many buildings. We find it, for example, in the Hearst Tower, we find it in Beijing in the CCTV building, and we find it in this building in the Middle East and in other buildings. We find the digrid. This is in the Capital Gate in Abu Dhabi. There is less obstruction to the outside view. It's avoiding interior and corner columns and providing significant flexibility in the floor plan itself. Now, because of this form of the building, as it reaches the top, as it reaches the pinnacle, it has got a glass hood or a glass hemispherical, a conical canopy on the top of it, and because of that conical canopy also in the digrid frame, it results in this topmost restaurant and bar space at the most upper level of the building. The atria, it is vertically linked informal breakout spaces. So as we see here, you look down also, you'll find these breakout spaces. Each atrium has this breakout space. As you step outside the office, these windows, as I told you, are operable, and so when we need to allow natural airflow inside the building, they can be opened up. As a result of this, they become natural social focus places for refreshment and meeting within the building. So just like the Commerzbank has its sky gardens, the Swiss Re building or the Gherkin has its atria with its breakout spaces where people can stand and even enjoy some of the fresh air coming in through the operable windows. And it functions as the building lungs distributing fresh air which is drawn in through the open panels of the facade through the spiraling atria all the way into the building. Therefore, finally we can say that the London's highest occupied floor is in this building, which is the club room or the restaurant. It has got a spectacular 360-degree panoramic view of the city. It has got a very advanced building management system which is also there in the Commerzbank, and because of that use of energy saving methods, up to 50% energy versus a conventional tower can be saved in the Swiss Re. The 6 shafts or the atria work as natural ventilation systems for the entire building. Now when it comes to wind resistance, facing up the lateral wind force, and there are 2 primary methods. We can control the wind excited sways that happen to tall buildings either by increasing the stiffness of the building or by providing tuned mass dampers or mass dampers, as we will see later in the type A 101. This is the damper, and it helps through the principle or the law of inertia to dampen the sway in the building. We will see that later. Whereas in the case of the Swiss Re, Ovaro, the engineering firm, went in for the digrade frame which makes the building stiff without additional reinforcement. So they have gone for making the building stiff to face the sway as a result of the lateral forces. This slide, we will be ending with this slide showing the various forms of tall buildings within the area of the gherkin. We have, for example, the high-tech building, the Lloyds of London, in the form of a factory aesthetic by Richard Rogers. We have the Gherkin by Norman Foster, and then we have the very standard moment frame glass and steel skyscrapers that had come up in the 1950s, 1960s, 1970s, etc. So a whole collection of different types of tall buildings are in this area. So what we find through this presentation is that what began as a very simple exercise in the 1890s in Chicago to develop the tall building has come so far and evolved so much further into so much innovativeness in technology. Structurally, climatically, in terms of energy efficiency, lot of changes have happened by the time we step into the early part of the 21st century. We will carry on from here into the next presentation where I will talk of other such buildings which have got innovative features in them and they use some of the latest technologies that are available to us today. Thank you.